My name's Ron Ortloff. I'm a program manager on the Azure SQL Data Warehouse team, now known as Azure Synapse Analytics. Today we're going to be talking about maximizing your return on investment using enhanced workload management. So the whole area of workload management has been a pretty substantial area of investment for us in the data warehousing space. So we're going to cover some of the new innovations, some of the things that we've recently released, and then talk about how these capabilities fit into scenarios that people run into challenges with every day when managing data warehouses. So when we think about data warehouse and data warehousing solutions all up, we've got demand coming into the data warehouse from all different directions. You've got stream analytics, streaming data in, Azure Data Factory, pipelines, loading data in, ELT transformations, stored procedures, CTAS operations, Azure Data Lake, importing data from the data lake, exporting data out to the data lake, and then on the right-hand side here, just a bunch of different end-user tools. So you've got Power BI reports running, ad hoc queries coming in from data analysts, building Azure Analysis Services cubes, and then custom apps. So what people, for the most part, do today is coordinate these things or orchestrate these different workloads through time. I'll run my data loads in the evening because that's when most people are at home. It doesn't necessarily make sense from a business perspective, but that's what I have to do to manage the resources I've been given. So this is where workload management can come and help in these types of scenarios. So when we think about workload management and what it means to really manage a data warehousing workload, think of this sort of continuous cycle where I monitor, understand how my workload is utilizing resources, understand what my business SLAs are, my business objectives are, analyze that, configure, address the resource needs of the things that have the highest business priority, and then continue that cycle. As user volumes increase, as data volumes increase, we'll want to go back to that monitor, analyze, and configure cycle. So with all that said, we've introduced the new kind of 3 pillars of workload management inside of SQL Data Warehouse. So we've introduced the concept of classification, the concept of importance, and the concept of workload isolation. So let's talk about these 3 in a little bit more detail. So first, workload classification. Workload classification is a process of assigning requests based on a set of rules to a workload group and setting a default level of importance. So just curious, quick show of hands, how many people do we have out here are currently SQL DW customers today? Oh, fantastic. All right, great, good to see. So today this is done via, your classification is done today via SP add role member. You're taking a set of users or roles and you're mapping them into resource classes. So what we've GA'd already and released is this new syntax called create workload classifier. So instead of using SP add role member to assign resources to users, you can use the create workload classifier syntax to do that same resource assignment. What we're announcing today for public preview though is the ability to go beyond just classification based on users and roles. So we're introducing the capability to classify based on a query label. So your option label query that you have, you can classify based on that. You can classify based on session context, and you can classify based on time of day. Okay, so some of the users out there, maybe, but it is a pretty common pattern. They'll create multiple logins to have different resource assignments for their queries. I may have some big, large fact table loads that I need to do, so I'll create a medium RC user, and I'll do all these kind of SP add role member, drop role member to move users in and out of resource classes. All these silly hoops that you do to get around that can be fixed here with this create workload classifier syntax. So this is the syntax. Again, this has been GA'd now for a few months. The create classifier, workload classifier, specify a workload group name or a resource class, the member name, and then you can set the importance, and there's 5 levels of importance. What we're announcing today here for public preview is the label syntax, the session context, and then start time and end time for time of day. We'll do a demo on this in just a quick second here to kind of drive the point home a little bit. Let's just touch real quick on importance. So workload importance is about assigning priority to the highest business value work that you have. So our scheduler today has basically been a FIFO based. I call it optimistically FIFO, where the first thing that comes into the scheduler queue is the first thing that's scheduled. In certain scenarios with locking conflicts and resource conflicts, we will have things kind of jump the queue, but for the most part, it's FIFO based. And there was no method for you as a user to really influence the scheduling of queries. So now by using the create workload classifier syntax and importance, you can tell the scheduler what the most important business value work you have is. Okay, and then we'll schedule that accordingly. All right, let's take a look at a demo here. Can folks see that okay in the back? Is that okay? Yep, okay. I got the 200% zoom here, so hopefully that helps. Okay, so what we'll do here is we'll create a couple different classifiers and we'll show how this all comes together. So the first one that I have here, this is just a basic classifier. It's going to assign this ad hoc user low importance and put them in the small RC workload group. And then we'll run the query. I'll create another classifier here. This is a create workload classifier. Put this one in medium RC with the ad hoc user. I'll set the importance to high, and then I'll specify the label of sales report. So now when I run this query, I have the option label syntax here, and this label maps to here with sales report. Okay, so you can see how these tie together. And then when we take a look at DM exec requests, so we've added a few new columns into DM exec requests now. You can see the importance here. So the second query was one with high importance. The first one was run with low importance. The group name column has been added, medium RC versus small RC, the classifier that was used, label and no label classifier, and then the resource allocation percent. So 10% for medium RC and 3% for small RC. So these are all new columns here that we've added in for workload management. Okay, so that's label-based classification. Let's take a look at, first let me clean this stuff up here. So let's take a look at session-based classification. So session-based classification, we're actually setting a parameter within the session context and then classifying based on that parameter that we're setting in the session. Okay, so here, again, the create workload classifier syntax. I'm setting the WM context parameter equal to fact load and the importance equal to high. So with that created now, I can use this system stored procedure called SP set session context and set the WM context key and the value equal to fact load. So fact load matches to fact load here, WM context matches to here. So you can imagine having a stored procedure where you want to run multiple statements kind of back to back and not have to put an option label syntax on every single one of those queries. So I could set at the start of my stored procedure, set this session context, run multiple statements now, and then they would all classify based on that session context that I've set. Okay? So here I'll run multiple statements now, and then we'll take a look, and we see that they used the session classifier that I created here. Okay? So they were classified using session context, set into medium RC with high importance, and given a 10% resource allocation. Now when I want to turn that off, then I use the WM context, oops, not that, down here. I set the value equal to null, and then that turns off the session context. Okay? The last one we'll take a look at here is time-based classification. So I mentioned at the outset, like, people are using kind of time-based orchestration based on when things run and when they have free resources. Now you can automate some of that stuff using time-based classification. So in this case, I'm going to create a workload classifier, and I'm going to say that this becomes valid between 0400 hours and 2300 hours. In this case, maybe I have a scenario where I want to set the ad hoc users into the small RC resource class and then set their importance to low. So anytime they come in between 4 a.m. and 2300, they're going to run under this context. Okay, and then if I run them, then we'll see that they use the time-based classifier that I created up here, get a 3% small RC and a low importance. So that's time-based classification. And those are the three new classification parameters that we've introduced here now for public preview. Switch back over to here. Okay. So now, kind of the main topic that I want to talk to you guys about today was we've released workload isolation now for public preview for SQL Data Warehouse. So workload isolation basically gives you the capability to create within your data warehousing instance separate virtual clusters. You can create your own dedicated amount of resources and then use that classification syntax that we just demoed and map your requests into that isolated set of resources. Okay, so through the concept of workload groups, you can reserve and dedicate resources to requests. You can define your own amount of resources per request. Who here knows what a concurrency slot is? Who doesn't want to know what a concurrency slot is anymore? Okay, they're gone. Okay? We talk about resources now in the concept of percentage of overall system resources. No more concurrency slots. Okay? So if I want to assign 3.25% resources per request, I can do it. Okay? If I want something between small RC and medium RC, like a 7% memory grant, I can do it. Okay? It's up to me. I decide what I want my resources per request to be. Okay? I can also cap and limit the amount of resources that a particular workload group would consume. We have a lot of customers today that have to give access to a bunch of ad hoc users that may not necessarily know what they're doing. I can set a cap on the amount of resources that a workload group can consume, and that's the most damage they could technically do on the box. Okay? So I could say these ad hoc users get 20% of system resources. When they've consumed up to the 20%, they'll start queuing. Even though there may be other resources available on the box, I can artificially limit them. And then we've also introduced, we've got a placeholder here to start introducing execution rules. The first execution rule that we're introducing is a query timeout value. So if you have DBAs that are out there doing kind of the whack-a-mole thing and killing runaway queries, you can set a query timeout, say to 60 minutes, and then after 60 minutes, they'll get a nice error message that says, hey, you violated the workload management policy, your query's been canceled. Thanks for trying. Okay? That sort of thing. So let's drive this point home just a little bit more. So what we have today with resource management and resource classes, you have basically one pie of resources. And we know with Power BI, it can be very query intensive, sends lots of queries to refresh reports. If you have data loads that you're trying to do at the same time, they can end up queuing because Power BI is consuming all the resources. So now with workload isolation, you can create these workload groups. You can create one for data loads, one for user queries. I can write the classifiers that send the requests into those. So now, data loads has its own reserved space, set of resources, and user queries does as well. So when Power BI sends in all these queries, it'll have to queue on its workload group, and I'll still have resources dedicated and available to hit my data load SLAs. So the one thing that you also have with with workload groups is that's very important to understand. What I showed there in the previous slide was basically a 50-50 equitable sharing of resources between data loads and user queries. So that's kind of full isolation. What you can do is actually configure partial. I could say I want 25% for data loads, 25% for user queries, and then you guys can share the other 50%. All right, and I can even say based on importance, one of these workloads can get access to those resources first. So this will help you drive ROI on your solution. You can set data load SLAs or user query SLAs based on a certain percentage, and then operate on kind of a bonus tokens or bonus resources amount from that shared pool of resources. All right, this is the isolation syntax. So it's create workload group. You have a min percentage resource and a cap percentage resource. That's the min amount of isolation. That's the cap percentage is the total that you could not exceed. And then you have request min and request max resource grant percent. That's the amount of resources that you're allocating per request. You can set a default importance level, and then you have the query execution timeout in seconds value there. So that's isolation. Let's take a look at a quick demo here. Okay. So what I want to show you here, so I'm going to create a workload group here. This is called WG Data Loads. I'm going to configure an isolation for this workload group of 24%. You can see this on the bottom here. I'm going to cap the amount of resources that it can consume at 90%. I'm going to set the request min resource grant of 8%. So this gives a guaranteed amount of 8% resources to every request. And if there's resources available on the box, I can use up to 30% for each request. So we've created that, and then I will create a classifier to put the requests in there. I'm going to create a little bit of noise, a little bit of chatter on the box, so we'll have an ad hoc workload running as well with this workload group configuration. And then I'll create a classifier for that. So I'm going to start some queries, and then we'll take a look and see how things are running. So come back here and take a look at this DMV query. Okay, so what we have going here, I'm looking at completed queries. So what we can see is the load users, they're running with 30%. Depending on when the ad hoc query comes in and consumes 25%, then the load user will drop down to something less than 30%. So the system's kind of automatically managing for you, depending on when things come into the system, how you have it configured. I can go anywhere between 8 and 30%. So if there's nothing running when a request is supposed to come in, it'll go ahead and give you that max resource grant. So this is kind of that bonus tokens concept I was talking about. I've got these queries just running in a continuous loop here, so they're constantly coming in and interacting with each other. So you can refresh this and we'll see a different picture. Again, ad hoc's getting in there every once in a while, but there's always these queries that they're guaranteed to be able to run because I have some level of isolation configured for them. Okay, but when the system's underutilized, we'll get greedy, we'll take those resources and make our queries run faster. So that's all I had for you guys today. Thanks for joining. If you guys have any questions, come on up. We can talk then. Thank you.